So what is slowing us down? Well, we are going to use other like old school analysis techniques. If we were in real production code, we would have something like sysdig or datadog or statd, etc., etc. But here it's code that I wrote 2 years ago, and I want it to be small and simple and without dependencies on anything else. So we are going to use HTTPing. HTTPing is a little bit like ping, except that instead of just sending a packet to the machine and waiting for a reply, it's doing an HTTP request, and it's measuring how long it takes for the HTTP request to come back. So you can use HTTPing with any web service, and it will give you an indication of the response time. So here I have my two web services, RNG and Hasher. They are exposed to the outside world. Remember when I was doing Docker Compose PS? Okay, now I have like tons and tons of things here, so I need to scroll back up. But here I see that RNG is on 8001, Hasher is on 8002, and if I look in the Docker Compose YAML file, this is confirmed, like, yep, RNG is on port 8001. Great, so I'm going to do HTTPing localhost 8001. How fast does this web service respond to me? It's taking like 2,700 and something milliseconds, so 2.7 seconds, which for a local service is really slow. And just to convince us, I'm going to ping the other service on port 8002, and the other service replies in 1 millisecond, which is much better and much more typical for a local service. So it looks like the first service, the one on port 8001, has a problem. Which one was port 8001 again? Yeah, it's RNG, the random number generator. It looks like the random number generator is not very fast. So at that point, we could wonder, okay, what is going on? And we are going to ask like a friendly old Linux expert, and they are going to tell us, oh yeah, I know why, that's because of entropy. So we're like, what is that? And if you are like a physics major, you know about entropy, and it's almost the same kind of entropy, but not quite, on Linux and on other systems as well. Well, generally speaking, a computer can't make up random numbers because it follows a program, so the program has to tell it what's the random number. Like if you had to ask a random number to a computer, it would tell you 5. And then if you ask to another computer running the same program, it would also tell you 5. And so it would not be that random. The computer needs to find something external that would be random. For instance, we could tell the computer, check the temperature outside and take like the fifth digit after the decimal point. So if the temperature is like 22.35679, take that number, and that's your random number. That would be a fairly good like random number generator, because the fifth number after the decimal point is pretty random. And actually, hardware random generators work exactly like that. They will use like thermal variations, stuff that is so random that it's random, if I may say. So when you don't have one of those generators, what the computer is using is stuff like the time between keystrokes on the keyboard, because that's also pretty random, or the time between packets on the network interface, or how long did it take for this disk I/O to complete. And again, you don't take the value itself, but you look at something after the decimal point where it gets like completely random. So this is why maybe you remember if you generated like SSH key or PGP keys a while ago on slower computers, it takes time and it tells you, please move your mouse. And you're like, I'm generating crypto keys. Why do you want me to move the mouse? Well, precisely so that it can measure the time between mouse movements, which is going to be random, and generate good randomness. So the way it works is that the kernel has many little bits in drivers, etc., to collect this entropy. It puts them in an entropy pool, and then when you generate random numbers, you get entropy from the pool. That could be a good explanation why our service is stuck. Like RNG is slow because it's getting bits from the pool, etc. It's a completely fake, excuse my French, bullshit explanation, but we're going to buy it anyway because it gives us a good excuse to scale the cluster. But before doing that, we are going to clean up and remove all these containers. So Docker compose down. Docker compose down is doing basically Docker compose stop and then kill and then rm, and then it's also removing all the other resources that might have been created. And in that case, that includes a private network for the application.